Well, hello, and welcome back. I'm AJ O'Neill, and I'll be your instructor for tonight's Beyond Code Live. And tonight we are going to be talking about why there are so many languages, kind of more about the philosophies, the manifestos, the core values, but that's kind of all part of it. And if at any point during this video you kind of have an aha moment or something really clicks for you, go ahead and give it a thumbs up. And with that out of the way, I will go ahead and get us started. And also, if you're joining in live, I do have the YouTube and the Twitch comments open, so I'll try to keep an eye on that as we go. This will be a little bit of a shorter one, I think. Well, we'll see. I shouldn't say that. We'll see how long of a one it will be. All right. So, I think what I actually want to start with is this list. No, we'll go with this one. So we have different programming languages because there are different philosophies as well as different technologies. So as programming has progressed, things have changed. Hardware has become different, and the internet has changed the way that programs work asynchronously, meaning that one program does some small amount of work here on a phone or on a desktop, and then another program is doing some amount of work out there somewhere. And so we have actual differences as time progresses that mean that we do need different languages because they have different features and they're tuned for different things. A great example of this would be that Go is very much a modern web app language. It is designed to be easy to work with on teams, to do really well the types of things that we need web applications to do and internet-based applications to do. And so we have we have these updates. C and C++ are terrible languages today. They're not good languages to use. You'd want to use something maybe like Rust or maybe like Zig. Python has become quite dated. It does have some places where, just like C, for historical reasons, people still use it, but it is not up to par with modern programming. But more importantly than the technical reasons, I think, is the philosophical reasons. So I will show you the Zen of Python and the Go Proverbs at least, and we might take a look at the Agile Manifesto, which is not really about programming languages per se, but rather just I want to give you this understanding of when you learn a programming language, you're joining a community, and it is a good idea to investigate the community and see if it's a community that jives with you, if the values that are shared in that community are values that resonate with you. So I'm going to go, here's a list that I've been compiling over the years, here a little, there a little, and it's not very complete. I'd love to get more in here, but we have the language, what the people of the language call themselves, or perhaps what others call them, and then what their manifesto or core values is. So a couple of the languages that I have that for are Clojure. Clojure has the Clojure rationale, and it's not surprising that Scala has the Scala rationale. They both call theirs the rationale. Go has the Go Proverbs. Python has the Zen Python. React I'm not really clear on what React's canonical philosophy is. It might be either this thinking in React or React hooks. Rails has the Rails doctrine. So these are all manifestos. And actually, let's go ahead and take a look at some. So I want to start with the Zen of Python because it's the first that I encountered, and it has had a huge impact on me and what I believe about programming. So let's go over this one. Beautiful is better than ugly. So it's good for code to have an aesthetic. Explicit is better than implicit. Now, this is something that you would need to have programmed to really understand. But this is basically saying it's better to have to write a couple of extra lines of code than for magic to happen. And the opposite of this, which Ruby adheres to, would be convention over configuration. So people say explicit is better than implicit when they say I would prefer to write a couple of lines than to have to guess at why something happened the way it did. And then convention over configuration is the approach of I would rather things be very succinct and just trust that the platform is doing the right thing. And React is also very much that way, very much not in the arena of the Zen of Python. Simple is better than complex. This is something I also subscribe to as well, and something that proves to be true economically. We have, for example, the Apple just released the M1 processor. It's got to be 100 times cheaper for them, and it ends up being faster. Using simple components together is usually better than using more complex components. And we'll see how this plays out with things like phone cameras. Now that they're adding 3 simple cameras to a phone and achieving results that $1,000 lenses are able to achieve, it'll be interesting to see how that goes. But this is something that often rings true in life, that taking simple measures, color movies, Technicolor was a simple black and white process repeated 3 times. So this is a philosophy not just in programming, but in manufacturing and economics and other areas of life. Complex is better than complicated. That is a nuanced difference. I think that it speaks for itself more than I can speak to it. Flat is better than nested. Now, this is a very good one. When I look at code, I've talked about this before, I prefer to error out early, to find a way, if there's a loop or if there's a condition, to find a way that we can end it early. And what this means is that instead of having if successful and then if successful, and having code that is deeply nested where there's lots and lots and lots to read, you end up with code where it's mostly flat. There's not lots of nesting. And this is also true architecturally. The number of files that you have in a folder, it is often more desirable to have a folder that you can search through that has maybe a couple dozen files in it than it is to have many, many, many different folders with folders inside of them that all have a few files. So this is, not everybody subscribes to this philosophy. Again, in the React community, you'll find quite the opposite. Lots and lots of nesting and lots of very little done per file and very many files and very many folders. But this is a philosophy that I subscribe to. We have sparse is better than dense, and I think that that's kind of in the same vein as a lot of what's already been said here. Readability counts, meaning that it is important not just that a program run well or run fast, but that it is easy to read and reason about. So in many cases, it is better for us to write programs that are less, quote unquote, efficient by certain standards, and to have them be very easy to read and understand, unless we discover that the small difference in performance is significant enough for a particular use case, or that it turns out that the difference in performance is actually significant and countable and matters. So readability is an important metric. Special cases aren't special enough to break the rules. I like this one as well. There are a lot of times where we say, well, let's not follow the rules for this particular example because it's a special case. Oh, excuse me. But the Python ideology is that you try to follow with the conventions and the rules as best you can. And I don't have a good example of that off the top of my head, but I understand what this means. And you will come to understand what it means if you don't intuitively get it. Although practicality beats purity. So this meaning that it is more important to be pragmatic than to be pure. And I actually came across an example of this today. There is an HTML. HTML, as I've talked about, is built for research papers and for screen readers and for search engines. It is not created for web apps. It doesn't have very much in the way of facilities that make sense for web apps. Some of the other components that we use on the web do, such as CSS and JavaScript, those are designed with web apps in mind, but HTML is really designed around the idea of a research paper. And there is an HTML. HTML has forms, and there's an element called label. And I had a little mini debate with someone about a special property of label, which is that it enables you to enlarge the target area of a form element, such as a button. And by target area, I mean the area where you click. So purists will say a label should only be used where it is appropriate to put a text label. But a pragmatist would say, well, there doesn't seem to be another simple and easy way to be able to surround a element that is a form element, and with very little work in a way that can easily be read and understood, enlarge the target size. So if you wanted to add a couple of extra pixels, especially when you have things that are round or have steeply rounded corners, etc., you often want to have the clickable or touchable, tappable target size of a button larger than the visual representation of the button. So a pragmatist would say, well, if we don't have a better way to do this that's easy to read and simple to use, then we can use an element for something that it wasn't intended for because it has the desired effect that is fairly easy to manipulate and use. So that's an example of practicality beats purity. Errors should never pass silently. This is something that is notorious in jQuery, PHP, JavaScript to some extent. We don't want code to run. Oh, and HTML, absolutely. HTML and CSS are horrendous about this. We don't want code to be interpreted and have an error and then just continue without the developer having a way to know what went wrong. So that's the idea there, unless explicitly silenced. So again, it could be that we look at an error, we inspect it, and we decide that we want to ignore it on purpose. And hopefully that's happening at the higher level, not down at the lower level. In the face of ambiguity, refuse the temptation to guess. This is beautiful, meaning that we want to have code that is not easy to confuse or interpret in multiple ways, which I think there's some areas where both Python and Ruby, in my opinion, are not the best at this in terms of how they handle some of their conditionals. But in general, the philosophy is followed in Python, that it should be easy to determine the right way to do something. Oh, here we go. There should be one, and preferably only one, obvious way to do it. Similar vein there. Although that way may not be obvious at first unless you're Dutch. Now, I think that the Guido van so-and-so, I don't know what... oh, no, this was by Tim Peters. Okay. So I'm not really sure. I think that somebody involved in this process was Dutch. I actually don't know the history, to my shame. And this is just a joke. So this is providing some levity. This is providing some humor, saying that part of the ethos of Python is to be lighthearted. Okay, now is better than never. You know, we want to make decisions, we take action. You've heard the phrase, a poor plan violently executed today is better than a perfect plan executed next week. So now is better than never, although never is often better than right now, which means that we want to be metered in our approach to decision making. So we do want to make decisions, make forward progress, but we also want to be tempered in that we don't make hasty decisions that could be something that we have to live with and regret. And in the world of programming, sometimes the mistakes you make live on for decades or forever. If the implementation is hard to explain, it's a bad idea. Meaning if it's difficult to explain what your code is supposed to do or what it does, then it probably isn't the best code. If the implementation is easy to explain, it may be a good idea. Again, it doesn't. This is one of those inverse, converse, contrapositive type things where we're saying this, we know it's probably a bad idea if this is true, but we don't know that it's certainly a good idea if the opposite is true. Namespaces are one honking great idea. Let's do more of those. Again, lightheartedness, humor, and namespaces are essentially a way to organize code together so that it is conflict free. So for example, that you could have two different pieces of code, both with a variable called name, and those can be independent from one another and not interfere with one another. And also, there's other areas where this is used, but basically being able to make sure that code is separated and that as bits of code are working with each other, that they can remain separate and useful in their own way, but still be involved with one another. So this is, I think, this is why Python. This is the why of Python. And I won't go through all of the languages that we had there, but I will also read through Go, and you'll find that it is very much the same, which is part of why I am such a fan of Go. That the Go proverbs and the Zen of Python very much align with how I am as a pragmatic programmer and what I try to preach and indoctrinate into other people as good code. And we can see that there are good fruits to this style of coding as well. So the Go proverbs are simple, poetic, and pithy. So even there, we have a meta description of them. Don't communicate by sharing memory, share memory by communicating. Now, some of these, are quite technical, so I'm just going to kind of skip over them because you may not be at a point where it makes sense for me to go into exactly what this means. But it's essentially a style of programming that you can. It is a way to be able to code safer programs that are easier to read and more likely to run correctly. Concurrency is not parallelism. These are two words that we'll have to. I actually think I already have them in the Jargon files. We'll go over that at some point. Channels orchestrate, mutex is serialize, again, very technical to the language. The bigger the interface, the weaker the abstraction. This applies to many languages. But an interface is, I'll give an example of the way that it works in Go versus something that's more typical, quote unquote, object oriented. An interface would be what defines that something is similar enough to something else. So let's say, for example, we have a reader as an interface. The interface is called reader, and the only bit of that interface is the ability to read. So if something can read bytes from a file or from a stream, then it is a reader. And a writer is something that can write bytes out to a file or a stream. And so there's a reader interface, a writer interface, and there's a read-writer interface. So these are very small. A read-writer interface is a reader interface with a writer interface. There's a read-writer closer, meaning that it can handle streams that can be ended predictably. So that's kind of a technical detail, but just to give you the idea, this is what a Go interface, what many of the Go interfaces look like. They are very simple, saying if it can do this one thing, then it's basically a thinger. If it can do a thing, it's a thinger. That's kind of how they approach it. In other languages, you often find that the interfaces become quite large and come with lots of dependencies, and they can become very complex and very difficult to reason about and difficult to use and require wrappers or layers around them to get them to behave in a way that's useful. So, for example, if you had a person interface might have, say, a person can speak, a person can greet, a person can purchase, a person can sleep. And so you might have many, many things that a person can do that are described as a person interface. And the way that interface would be, let me try to dumb this down to kind of a more consumer level. Actually, I have a really good example in my bag right here. If I can find it. Okay, here we go. So this would be a complex interface. Can we get this in frame? Oh, not so much. Let me try there. Okay, so this is a USB-C hub, and it has lots of different ports on it that do lots of different things. So it has many interfaces. So if we were to describe exactly what this USB port hub is as an interface, if we were to say that something requires all of these ports and that was the interface that it required, it would require an SD card, a mini SD card, a USB 3, a USB-C power, an HDMI, another USB 3, and a USB-C data. So that's quite many things. It's very, very highly specific. If we were to consider the interface of, say, this camera, let's see, can we get this in focus? Are you going to come in focus? No? Okay, well, that's fine. I'll just pull it back towards me. It is a very simple interface that's called EFS. And anything that can attach here matches the interface. So the lens is the interface to the camera. And you know, it's a literal interface. And this is very simple. It's very simple to describe. Every Canon EFS camera has an EFS mount, and every lens that is EFS compatible fits on the EFS mount. Done. And that's kind of the difference between a very generic and small interface, something that is easy to describe and easy to define compatibility with, versus something that is more complex and maybe more feature-rich, but more difficult to say whether or not it's generically useful. Because, for example, for some hub interfaces, I might want to have an Ethernet port, or I might want to have two HDMIs, etc., etc. So the ability to define what features an interface should have are very analogous to the physical world. It is very difficult to buy a USB hub and know if it's the thing that I need, because I have to go look at every individual detail. And I might have to use some other adapter on it to get it to do the things I need it to do, because it may not have what I need built in. Likewise, in programming, we can have interfaces that are complex and that have things that we don't need, and maybe things that need to be plugged in. Like, for example, some of the hubs have to be plugged into power in order to work. So not only do you have to plug it in to the data, you have to plug it into power, et cetera, et cetera. So I know this is, I'm trying to build out something that's analogous here. So make the zero value useful. I'm going to move on from that. Make the zero value useful, meaning that when you don't use a variable, when you've just set a variable in Go, it does something very sensible. Boolean variables are false by default. Integer variables are 0 by default. Float variables are 0.0 by default. String variables are empty strings by default. And so what it's saying is, with what the default value of something is, do what you can to try to make it so that the default value is an acceptable value, so you don't have to do lots of initialization. How can you use a variable in such a way that it doesn't require as much initialization? And this is good because oftentimes we forget to do our initialization. So if we can follow this principle, then we are less likely to have bugs. And an example of that is, again, I've talked about reversing things in programming quite often. An example of this would be to let's say that what you want to know is has umbrella, and the default value of has umbrella would be false. There might be a case where it would be more valuable if the person, and I'm thinking of umbrella because it's raining outside right now, but if the object was going to most likely have an umbrella, then maybe the value should, and the default should be assumed that the person object has an umbrella. Then what we could do instead is say doesn't have umbrella, which is a double negative and can be kind of awkward, but then we would not require an initialization. The default object would be assumed to have an umbrella, for example. Okay, empty interface says nothing. that I won't go into because it's a more technical detail. Well, I will a little bit. It basically is saying don't make things too generic in your code. Don't lose the pragmatic use of your code to try to make it too generic. It's better to have, say, two functions that do similar things that are more specific than it is to have one function that is particularly generic. Go format style is no one's favorite, yet Go format is everyone's favorite. So one of the things people like to bicker about in a language is where spaces should go and how many spaces there should be and how many new lines there should be and where brackets should go and where commas should go and where semicolons should go. And Go has a tool called Go format that just does it the way that it's supposed to be. And so you may not like the way that it formats it. You might prefer there be 4 spaces instead of 2 spaces or whatever it is. But it doesn't matter as much what you prefer as it matters that we all have common code, and when we go to share code with one another, we don't bicker and argue about, oh, well, the code should have 4 spaces, or the code should have 8 spaces. No one uses 8 spaces. The code should have 2 spaces. Heaven forbid the code should have 3 spaces. But these types of stupid decisions that just waste time, it gets rid of it. And Rust is the same way. Rust also has a Rust format, and more languages have a format command. Dino has a Dino format command. It's becoming more and more popular to say, look, the programming language should just be a certain way, and we don't need to debate it. A little copying is better than a little dependency. This is a beautiful, beautiful, beautiful thing. Just as we were talking about before, sometimes it is better to have 2 copies of a function than for something to be generic. It is also often better to copy a small snippet of code from somewhere else in the code than it is to create a separate file for that small snippet and then to require in or import in that separate piece of code and then have a dependency on this other external file or package. So this is something that is valued in the Go community, and I think it's absolutely great. Syscall must always be guarded with build tags. This is basically about protecting cross-platform compatibility. So programs should work on Windows, Mac, and Linux all the same, is basically what this is saying. And that if it doesn't work on Windows, Mac, and Linux all the same, then it should be handled appropriately. There should be a flag in the code that handles that particular case so that it's clearly documented and the build doesn't break unexpectedly from you when you go from one computer to another. Syscalls are what are different between Windows, Mac, and Linux. CGO must always be guarded with build tags. This is pretty much saying the same thing, more or less. CGO is not Go. So Go, most programs can be built with C code. Maybe not most, but for example, all of the interesting things in Python about machine learning and artificial intelligence, none of it's written in Python. It's all written in C. And Go is a very fast language. Python is a very slow language. So in Python, you must build many things in C because otherwise they'll be terribly slow. Go is a very fast language, so it's not necessary to build things in C. But sometimes there is some C code that has already existed for the last 30 years, and you want to use that so that you don't have to rewrite it in Go. And the same thing is true with Rust, but CGO is not Go. Now Zig, on the other hand, flips this around a little bit. C is Zig, but Zig is not C. The Zig compiler can compile C. Let's see. With unsafe packages, there are no guarantees. This is common in many languages. There's something called unsafe, which allows you to do things that you generally shouldn't do, but you might need to do for some particular reason. Kind of going back to the Python, special cases aren't special enough to break the rules. There are some cases where it is unavoidable to break the rules, and in Go, those are marked with an unsafe package. It allows you to break the rules, but it's very clearly documented. It is very easy to audit, and there are people that will not run code that has marked unsafe code in it because they know that it could be potentially dangerous, vulnerable to viruses, or to causing crashes, etc. Clear is better than clever. This, I think, was pretty much said in almost the same way in the Python one. Something like that. Yeah, it is better to write code. Which one was it? Explicit, simple is better than complex. Complex is better than complicated. Flat is better than nested. Yeah, I think it's kind of all encompassed in there. But it is better to have code that is readable. Oh, what? I think there was readability counts. There we go. That I talked about that there. It is better to have code that is readable and understandable and that is communicative than it is to have code that is very cool or that is super efficient under some niche condition. Reflection is never clever. Technical detail. Errors are values. This one is something that you can do in most languages, although typically people do not. But Go has made it more clear how to do it. So you can throw errors or you can pass errors as a value. In just about every language where you can throw an error, you can also pass an error as a value. It's just typically not done, and this ends up, the problem ends up being that errors are not handled well. So which goes into the next part here. Don't just check errors, handle them gracefully. Design the architecture, name the components, document the details. So this is, we talked before about TDD and DDD and some of these ways that you can think about how you're going to design and test and build code. And this is a philosophy. First, think about what it is you need to do. So that's kind of maybe a level higher than the DDD. This would be ADD, architecture-driven development. But you design the overarching goal of what you want to do, then name the pieces. What should this be named? What should that be named? What should this be named? And then document the details. What should this receive? What should this output? What are special conditions that it might need to handle or special cases that somebody reviewing the code would need to be aware of when making a change? Documentation is for users. This makes sense because everybody who is a user of the program, the code of the program, is someone who would benefit from the documentation. So we want to write documentation in such a way that the people who will need it can understand it, just keeping the customer in mind, so to speak. And then don't panic, of course, which is just this idea of being friendly, being a little lighthearted, but also this is pithy because there is essentially, this is saying don't throw exceptions. So that's technically what they're saying is, going back to errors or values, don't just check errors, handle them gracefully. The last one here, don't panic. Panic is a type of throwing an error. So it's a double entendre. And also a reference, of course, to the Hitchhiker's Guide to the Galaxy, because so many of these documents do reference nerd culture. So I guess that was a little bit different of a vein than what I thought that I was going to go into when I started this, but I hope that this is kind of helpful in understanding that different languages have, and I kind of, the two that I went over were relatively the same, but I did explain some opposites. But different languages have developed because there are different conditions that exist in the world and different values that the people in that community like to follow. And so for me, I find that these two mini manifestos have a lot of things that I value in them. And then I also would do one more, the Agile Manifesto. I'll just maybe skim over this. We'll read the core bit here of the manifesto. Individuals and interactions over processes and tools. And that also, yeah, this is just really great. Working software over comprehensive documentation, customer collaboration over contract negotiation, respond to change over following a plan. So this is, people talk about agile development. Most of them have no idea what they're talking about because, well, not no idea what they're talking about, but basically people want to make money. And so they create certification processes and they create books and they create things that they can use to make a business model out of. So when Agile became a buzzword, people basically took the Agile Manifesto, which is these 4 sentences, threw it in the garbage, and then came out with several 100-page books that describe things that basically go fairly counter to this, and then called it Agile so that they could capitalize on the market opportunity. And if we wanted to go a little bit deeper into Agile, the 12 principles are, encompassed in about a page. So when when somebody's telling you that they're Agile certified and they're a Scrum Master and this and that, uh, this is the document that I would say, check this out, read this, and see if you subscribe to these things. And if you, a lot of this is stuff where once you've been in the industry a little bit, you've done some consulting, you've worked on a couple of different teams, what the Agile Manifesto is intended to mean becomes more clear. But it's definitely different from when people are hyping about like, oh, we're an Agile team and we follow XYZ paradigm. That's not what the Agile Manifesto was about. So Agile programming no longer means, it's kind of like one of those things where somebody says would you mind helping me with this? And you should say no, because the correct answer to would it bother you to help me would be no, if you intend to help them. But people often say yes. Would you mind doing such and such? Yeah. Well, they're answering the affirmative, yeah, I'll do that. But the actual literal interpretation would be, yes, it bothers me to do that, which is not what people mean. And that's kind of what Agile has become in a way, is Agile has gotten thrown in the garbage, and then the word has been reappropriated to mean something that it didn't mean. But anyway, I digress. I would say that this kind of belief system does flow into other, like this came out before the Go Proverbs did, and I feel that some of the ethos of what is in the Agile Manifesto lends itself to certain languages. I would say that Java would not feel like a language that is an agile language, for example. And I'm kind of mixing the difference between a language and a methodology, but anyway, that's there. So, we've got a lot of different languages out there, and the reason is because they subscribe to different ethos, different philosophies. People want different things from them. And so do a little bit of research, figure out the thing that looks like it will be good for you and your career path and what jives with you. And that's going to take learning and experimenting. It's not something you can just go read one of these things and understand, because like I said, and as you probably observed, you have to have done a little bit of programming to know why it bugs you when things are implicit. I hate magic. I hate it. I hate having to search through code to find out where something happened and it isn't there in the code because it was built automatically at runtime, which you may not even know what that means, but I can't stand it. I hate it. It bothers me to no end. It's one of the reasons that I don't like React. React is so much magic, and I have been able to break down parts of it to understand how it's actually doing what it's doing, but it's not something that's clear in the documentation, and it's not something that is clearly configured. Other people feel the opposite way. They feel they do not want to know the internal details. They don't want to bother. They assume that nothing will go wrong, and they don't color outside the lines, and so they don't encounter the cases where they need to go against the grain to solve a problem as much. I am the type of person where I do end up having to look deeper into tools to get at specific details, because I do work that is often in protocols and whatnot. So for me, this is something that really jives with me. For you, it may not really jive with you. And if that's the case, then Beyond Code may not actually be the right course for you, which is fine. You can find other courses that are. But this drives a lot of my decision making when I feel that the ethos of a language aligns with the way that I like to program. I tend to identify with it more. And an example of this where it's gone backwards is JavaScript. JavaScript, the Crockford was at one point in time kind of the leader, the thought leader in the JavaScript community. And he was very much aligned with these types of principles. And then some other people took over, and it became a design by committee language. And a lot of his ethos were thrown out the window, and other ethos were adopted. And so I do not like programming in JavaScript that much anymore. Or at least I enjoy programming in it the way that I like to program in it, the way that is the Crockfordian style. But I do not like the React style, for example. And as I look at Rust, there are some things that I really, really love about Rust. and there are many things I really love about Rust. Rust is a beautiful language, but there are some ethos in the community where they often, let's see, I think they're, I'm not going to go into it, but there are things that are needlessly complex because they're never brought into the standard library. And there's a saying that you will hear eventually, the standard library is where things go to die. But it's not. The standard library is where things go to be complete. We don't need everything to change all the time. We need new innovations. But it's kind of like the wheel. Once you've designed the wheel and you've got a good wheel and the wheel works and the bearings are good and the general design of the wheel is good and it can fit the tires that it's most likely to need, well, let's call it the wheel V1 and let's ship it. And if somebody needs a wheel that is more like a tank track, it's okay. They don't need the wheel that is the standard wheel. They can have a non-standard wheel. But we don't need to prolong not deciding on a wheel V1 because we don't know every possible use case that could ever happen with a wheel, and we don't have a satisfactory answer for every possible way to ever use it. And I feel like that happens a little bit in the Rust community, where there are simple decisions that could be made that would not work for everyone, but that those people could easily opt out of. And instead, it's just kind of left up to, it just doesn't happen. Anyway, I'm a topic for another time. So again, if this was useful for you, if you had some aha moments, even if it perhaps went a little bit differently than what we thought it was going to be when I did put the title and had started putting the material together, go ahead and give it a thumbs up. If you want more like this, subscribe and hit the bell for personalized notifications if you're on the live stream channel, my personal channel. Otherwise, go ahead and subscribe and get everything on the Beyond Code channel. Links to that are in the description. And I am still working on the HTML material. It turns out that there are, when I go to teach something, I often learn new things about it that I didn't know before. And that is the case with pretty much everything that I teach, because I want to be more exact when I'm teaching, because I am imparting wisdom and knowledge to you, and I want you to have the best wisdom and knowledge that is available. And so I dig a little bit deeper. And HTML on the surface seems very simple, like what I showed in the what HTML is not video. But when we actually try to look at it in terms of teaching what HTML is and what are the most useful parts, there's a lot of legacy crap that doesn't matter. There's a lot of new crap that doesn't matter. There's a lot of new features that are actually important. And there are a few nuances, like what I was explaining earlier with the way that a HTML label can work that is different from any other element. It is a very specific purpose that I'd never actually cataloged in my brain before. So as I go through this, I'm trying to find the right way to present the most important information in a digestible way, and it's tough. So it's taken me a little bit longer. That said, we'll see what happens tomorrow night. You have a good one. Adios.